All right, so here's the first problem. A fair die is rolled. What is the probability that the number rolled is a factor of 6? Well, first of all, you have to know what a factor is, right? What are factors of 6? 2 and 3. What else? 1 and 6. So we want to know what the probability that the number rolled is a factor of 6. Oh, great. You can't even see all those. 1, 2, 3, and 6. Bless you. All right, so those are my factors of 6. So probability is the number of successes out of the total number. So if I have a die with the numbers 1, 2, 3, 4, 5, 6, what is my numerator, the top number, going to be? Alex? Huh? What is the probability that the number rolled is going to be a factor of 6? What is my numerator going to be?
6.
No.
4.
4. Yes, because any of those 4 that I would roll would work. So that is 4 out of, how many total could I roll? 6. 4 out of 6. So these are my successes, rolling any of those, and then I have 6 total. What questions do you have about that one? All right, let's take a look at the next one. 2, now we shouldn't call it dice. I mean, that's just morbid, right? Should be 2 dice. 2 dice are rolled. The probability of getting a 6 on one die and an even number on the other is 0.083. Are these independent events? Well, this is what you were supposed to have looked at yesterday. I gave a video. I saw there were 9 people that did that. So, again, thank you, 9 people. But the probability of A times the probability of B should be equal to the probability of A and B. All right, so the probability of getting a 6 on one die and getting an even number on the other is 0.083. 0.083. Okay? The probability of getting a 6 on one die, what is that probability? 1 out of 6, right? Because if I get a 6, that's my one success out of the 6 different numbers that are there. And what's my probability of giving an even number on the other? 3 out of 6. Now, we had something similar to this, kind of similar to this on the skills check. When you are multiplying probabilities here, you have to multiply the top with the top and the bottom with the bottom. So 3 times 1 is 3. And 6 times 6 is 36.
Make sure that you guys have your ID cards and check your seat number on the roster outside of the gym doors. Thank you.
I need somebody to take 3 divided by 36. Tell me what that is. 3 divided by 36. 0.083 repeating. So because these are equal, now this one doesn't have repeating, but I think it'll work. Because these are equal, we are saying yes, they are independent events. Yes, they are independent events. And we're going to talk about that briefly today. review of what you should have done yesterday. But yeah, when you roll 2 dice, what you get on the first one does not affect what you get on the second one. All right, number 3, permutation or combination. Suppose you are asked to list in order of preference, that should be of preference, the 3 best movies you have seen this year. If you saw 10 movies during the year, in how many ways can the 3 best be chosen and ranked? Good morning, Leilani. How many different ways can the 3 best be chosen and ranked? Is that permutation or is that a combination? Who haven't I talked to? It is permutation. Yeah, order's important. And what's that mnemonic device we kind of can use? Pom-poms, permutation, order matters. So that's a permutation. And if you were to do that on the calculator, it's a permutation of 10 items, taking 3 at a time. So if you put that in on your calculator, you will probably get something like, let's see, 10 times 9 times 8. I'm going to say 720. All right, you should get 720. Okay. Any questions about these 3 problems? And we're going to talk about number 2 coming up here. Any questions? Leilani, are you ready to take the skills check from Friday? Okay. There you go. All right. Okay, let's go into our notes now. And let's see, I want to say we're probably on like 21. We are. Okay, 21. Now, I am not going to go over all of this because you were supposed to have watched it. Well, shoot. It's probably 20. I'm going to do a little bit on page 20. So, independence. What are independent events? Here we go. Independent events. Independent events have no influence on each other. So whatever happens to the one is not going to affect the second one. Okay? Oh, nice. All right. Independent events. Whatever happens to one is not going to happen or affect, it's not going to affect the second one. How do we test for independence? Looks like this. If the probability of A and B, if that is equal to the probability of A times the probability of B, if it is equal, then A and B are independent. Oh, sorry. If the probability of A and B is equal to the probability of A times B, then they are independent. If they are not equal, then they are not independent, which means they are dependent. Okay. All right. So, number 3. I'm going to do number 3 And I think number 4. Yeah, 3 and 4, and then I'm going to jump to the next section. So just a little bit more review for those of you that did see this. All right, so the probability of selecting a purple marble from a bag of marbles is 0.4. Purple marble from a bag of marbles is 0.4. The probability of selecting a big marble from the same bag is 0.55. The probability of selecting a marble that is purple and big is 0.3. Are the events selecting a purple marble and selecting a big marble independent? Okay, so here's where we use that formula. The probability of I'm actually going to put the marble stuff in. So the probability of purple marble, and a big marble, we want to know, is that equal to the probability of pulling out the purple marble times the probability of pulling out the big marble? All right, so the probability of purple marble and big marble, they give us that. So they will give us a number. And it says it is 0.3. 0.3. Okay? Is that equal to, and this is what we're questioning, is that equal to the probability of getting a purple marble, which is 0.4, times the probability of getting the big marble, which is 0.55. Okay, so if you take 0.4 times 0.55, you are going to get something that does not look like 0.3, if you ask me. What is it? 2, 3 here. Is that right? Yeah, 0.22 or 0.220. Those are not equal. So these are not independent, or they are dependent on each other. Okay? Any questions on that? A and B should be equal to the probability of A times the probability of B. If they are, they're independent events. If not, they're dependent. And let's take a look at this one on number 4. The probability that it rains on Monday. Probability of rain on Monday is 0.4. The probability that it rains on Tuesday is 0.2. And the probability that it rains Monday and Tuesday,
Is that minus or times?
this times. Rains on Monday and rains on Tuesday is going to be equal to 0.08. So we're asking ourselves, is that equal? Well, 0.4 times 0.2 is equal to 0.08, and that is equal to the probability of raining Monday and Tuesday. So yes, they are equal, and that means these are independent events. Independent events. Okay? Any question about 3 or 4? Okay. Now, I am going to skip for now doing 5, 6, and 7. If you did not see it or watch the video yesterday, you can watch it yet today or tomorrow. You can also copy it down from the notes. But we are going to go on to the additional probability practice on page 21. Page 21. All right, so find the probabilities of the events described. Number 1 says you flip a coin. You can just put it in that top tray. Yeah, those of you working on the skills check, just put it in the top tray when you're done. You flip a coin and then roll a 6-sided die. The coin lands heads up and the die shows an even number. Now, they don't give us any numbers here. We have to look at these and say, do we think these are independent or dependent? So 1, you're flipping a coin, okay? And the other is you're rolling a 6-sided die. Do you think how we roll or what we get determines how we get on the other one? Just say no.
Yes.
No, just say no. So we've got a coin and it lands heads up. What is that probability that it lands heads up? 1 out of what? 1 out of 2, that is correct. Probability of heads up on a coin is 1 out of 2 times the probability that we roll an even number. Probability of rolling an even number. What are my even numbers on that die?
4 and 6.
That is correct. 2, 4, and 6. So what is my probability of rolling an even number?
3 out of 1 and 3.
No, not quite.
Or it'd be like 3 out of 6.
Yeah, 3 out of 6. So you have 3 successes out of the 6 total, right? All right, so multiplying, and we said these are independent, so we can just multiply these together. Gives me 1 times 3 on top is 3, and 2 times 6 on the bottom is 12. So this probability is 3 out of 12. Three out of 12. So you do have to know what your even numbers are. Okay, let's go to number 2. This could be an actual problem. Daniel, come on, head up. Pay attention. So there are 8 shirts in your closet. 8 shirts. You have 4 blue and 4 green. You randomly select one to wear on Monday and then randomly select a different shirt to wear on Tuesday. You wear blue shirts both days. Okay, blue shirts both days. So the probability of wearing blue on day 1. What is that probability of wearing blue? How many successes could I have? A lot.
No,
4 out of 8. Yeah, because I have 4 blue. So it's going to be 4 out of my 8 total. Now, it says you randomly select a different shirt to wear on Tuesday. So you're wearing a different shirt. Is that with replacement or without? Like, are we putting it back in or are we not? The shirt. Yeah, if you wore it one day, hopefully you don't wear it a second. Sometimes I understand you have to. But, so how many blue shirts, if you wore a blue shirt on the first day, how many blue shirts do you have on the second day? 3 out of the total of how many shirts? Is it 8 or 7? 7, right, because you already wore the one the other day. So here are my 2 I'm going to multiply numerator times numerator. 4 times 3 is 12. 8 times 7 is 56. So 12 out of 56 is my probability. And I really didn't finish this. Probability of blue times day 1 times probability of blue on day 2. Question, are these independent events or are they dependent? Dependent, because what you picked on the first day helped determine what you selected on day 2. Okay? So those are dependent events. Number 3, you roll a fair 6-sided die twice. You roll it twice. The first roll shows a 5, and the second roll shows a 6. So the probability of getting a 5, and then the second roll, probability of getting a 6. Are these independent or dependent events? Independent, yeah. What you roll on the first one is not going to affect at all what you roll on the second. Okay? So what is the probability of rolling a 5, Daniel?
1 out of 5.
Close. 1 out of how many sides are on a die? 6. Yeah, there's the 4 sides, top and bottom. So that's 1 out of 6 times, what's the probability of getting a 6 on the second roll, Juanita? If I roll a second time, how many successes would I have to roll the 6? If I roll the die, how many faces have a 6 on it? You want some help?
Is it 6 out of 6?
6 out of 6? What do you guys think? No, that's a little high. Yeah, 1 out of 6, because you have one face that has the 6 on it out of the 6 different sides. So 1 times 1 is 1, and 6 times 6 is 36. So 1 out of 36. 1 out of 36. All right. Let's go to number 4. We're on page 22. 22. It says a basket contains 5 apples and 7 peaches. You randomly select one piece of fruit and eat it. Then you randomly select another piece of fruit. Is that going to be independent or dependent events? If you take a piece of fruit and you eat it, and then you go back for another one, is that independent or dependent? Dependent, because you ate one of the first, so it's not there for the second. So this is a dependent, these are dependent events. Okay, the first piece of fruit is an apple, and the second piece is a peach. All right, so what is the probability that the first is an apple? We have 5 apples, we have 7 peaches. What do I have to do before I can figure out my probability? Sarla? Yeah, I have to figure out how many I have total. So 5 plus the 7 peaches gives me 12 fruit to choose from. And from that 12 fruit, Kevin, what's the probability that I am going to select an apple? I have 5 apples and 7 peaches. I have 12 fruit total.
5 and 12.
Very good. 5 out of 12 times, okay, the second piece is a peach. Second piece is a peach. What do you think, Jason? 7 out of 12. What do you guys think of that? I don't know. It's pretty good. I like the 7. I don't like the 12 because, yeah, we already ate one, right? So you only have 11 to choose from.
7 out of 11.
Yes, it should be 11. So 5 out of 12 for getting the apple times 7 out of 11. Multiply top times top. 5 times 7 is 35. Over 12 times 11. Looks like 132. 132. You can just put it in the tray. Okay. 35 out of 132. So if you notice, independent events will go back to your original denominator. If you have a dependent event, sometimes it will be one less because you have one less item to consider. All right, last problem, 5A and B. It says, in a game, you chose a card from a box containing 4 red cards, 6 blue cards, and 5, does it say 5? Yes, 5 yellow cards. Yellow, let's get a yellow up here. 5 yellow cards. Okay. Letter A, you draw one card, look at it, put it back, and draw another card. What's the probability that on the first draw you chose a red or blue? Ooh, red or blue. There's or. And on the second draw, you chose a blue or yellow. All right. Probability of choosing red or, is or going to be a U or an upside down U? Nope, that's and. So it's for the union.
Oh, wait, that's right.
So red or blue. Red or blue. And on the second draw, we choose a blue or a yellow. Okay. So remember, the or, we want everyone to join. Okay. This is going to be probability of blue or yellow. So the ors, we want everyone to join. So we need probability of red plus, and this is the only time we have addition almost, okay? Most of the time we're multiplying. Plus the probability of blue minus the probability of red and blue, okay, times, for the second one, the probability of blue plus the probability of yellow minus the probability of blue and yellow. Just want to make sure I'm doing this right. Yes. All right, so probability of red, we have 4 red cards, 6 blue cards, and 5 yellow cards. Before I can start calculating probabilities, I have to find my total. So how many total cards do I have? Come on, people. How many total? When I say total, that means we need to add. So 4 plus 6 plus 5 is 15. 15 cards total. Okay. What is the probability of choosing red? What's the probability of choosing a red card?
1 out of 15.
No. How many red cards do I have?
4 out of 15.
4. I have 4, right? So that's going to be 4 out of 15. Plus, what's the probability of pulling a blue card? 6 out of 15. Minus, do I have any red and blue cards at the same time? No. So that gives me a total of 10 out of 15. Because when you're adding, you keep the denominators the same. And we are adding. This is one of the few times with the or statement where you add them. Okay? Times, what's the probability of pulling a blue card? 6 out of 15. Because it doesn't tell us what we get. We're just going by what we know. Plus, what's the probability of pulling a yellow card? How many yellow cards do we have?
5.
5 out of 15 equal, minus. Do we have any blue and yellow cards at the same time? We do not. So that gives me 11 out of 15. So I need to multiply 10 out of 15 times 11 out of 15. 10 times 11 on top is going to be 110. And 15 times 15 on the bottom is 225. 10 on the top times 11 and 15 times 15. Any questions about that? You have to remember that or is the probability of adding as many as we can get. All the first one plus all the second one minus the intersection. There's no intersection when you're talking about colors of cards. All right, letter B. This time, you do not replace the first card before choosing the second card. What is the probability of choosing a blue card first and then choosing a yellow card on the second draw? So what's the probability of choosing a blue card first and then choosing a yellow card second? Okay, blue card first. All right, so what's the probability of choosing a blue card? How many blues do I have? 6 out of 15 total. And it says you are not replacing that card back in. We are not. Okay. So what's the probability of choosing a yellow card? How many yellows do I have? 5. And if I don't put that first card back, how many cards do I have total? How many? No. I don't put it back. 14, right? So multiplying 6 times 5 is 30. Out of 15 times 14 is 210. So that means this is a dependent event. Dependent event. Okay? All right. Good job, guys. Those of you that were participating, I appreciate it. Any questions about these? Some that you're like, I don't see how we got that. All right. So, reminder, you should be working now on homework 7.4. This is the last homework that I am giving to you. Well, that's not quite true. I'll ask you to work on the review, but the last regular homework, I should say. Remember, this is on Canvas. You have 5 different attempts, 5 chances to get the highest score. Okay? This, I would like this to be due, I would say tomorrow. I mean, I think that will serve you the best. Tomorrow we will start reviewing. I will have a review packet, I believe, and we'll review that way. We'll review also on Thursday, and then the probability test is on Friday. Tomorrow also, I will pass back your skills checks so you can see those. And that should be a good way to help you study too. Okay? All right. Good job, guys. Keep looking over your notes, too. It doesn't hurt to look over your notes.